This is the Speedy Moisture Gauge, right? Kind of looks like a genie in a bottle. There's no genie in the bottle, unfortunately. So once we've taken our nuclear density reading in a particular location, we're going to have to take the moisture take a moisture determination of that particular location. Why? Because our gauge gives us wet density, but we need dry density. And dry density is determined or calculated using the wet density divided by the moisture content that we get from the Speedy Moisture Gauge. So what we're going to do is we'll take the nuclear gauge testing in the field at that same location where the random number fell for that nuclear gauge. We're going to take soil, the full depth of our radiation, our nuclear gauge testing, and we're going to dig some soil out. Okay, and we're going to put it in a waterproof container so that there's no evaporation or rain doesn't get into it. It's going to stay just like it was in the soil when we took the nuclear gauge. So in order to take the moisture test, we're going to pull this out. This is the Speedy Moisture Gauge. In here, in addition to the cloth and the brush we took out, we have a balance or a scale, right? And then we have some steel balls that we're going to use to mix our soil sample with our calcium carbide reagent. When our soil sample mixes with the calcium carbide reagent, it creates a gas, and that gas is going to be measured here on my dial. That dial tells me how much moisture is in that particular soil sample. So we're going to do that. Here's the reagent. Be careful with the reagent because it does, when it mixes, it creates acetylene gas. So we're going to put these things out on the table here. And the first thing we need to do is, just like with the nuclear gauge and with the rolling straight edge, we need to be sure that they're properly calibrated. This has to be calibrated within every 6 months. So it has to be calibrated within every 6 months. Another thing I need to make sure of is that my needle is on 0, right? If it's not on 0, there's probably something wrong with my gauge. We have our Speedy gauge. We have some steel balls that we use for mixing our reagent with our soil. We have a cup for measuring 20 grams of soil that I'm going to mix with 2 scoops of my reagent. Okay, 2 scoops of my reagent, 20 grams of soil. Okay, now before I begin, what I might want to do is, if the person who used it before didn't properly clean this gauge, we're going to take the brush, right? And we're going to clean the bottle out with the brush. Then we're going to take the cover, and we're going to use the cloth on the cover because I have a rubber gasket here and I don't want to damage it with the brush. So I'm going to use my cloth on it. And I also recommend that you use the cloth over here on the top so we don't score it or anything, and to be sure we get any sand or anything that might be stuck there. So the first thing we're going to do, according to FDOT, first thing we're going to do is we're going to take our reagent, our calcium carbide reagent. We're going to open it up. All right, we're not going to open it because it does react with moisture in the air. But we're going to take it and put 2 scoops. Why 2 scoops? Because this tester is a 20-gram tester. So we're going to be testing 20 grams of soil. In here, we use 2 scoops. The other size is a 26-gram tester. In that case, we would use 3 scoops of the calcium carbide. So my calcium carbide is in there, right? I want to kind of cover it to be sure that moisture in the air isn't going to be reacting with it, because the humidity in South Florida is fairly high. Now, once my reagent is in here, I have to put my balls in, right? But put the balls in, and I'm going to turn my gauge sideways, horizontally, and I'm going to drop the balls inside of my gauge, and then I'm going to stand it up, right? And put my cover in upside down. Why do I turn it horizontally? Because I don't want the balls, the steel balls, to damage my gauge down here, damage my sensor. I don't want it to damage the sensor. So I'm going to turn it sideways. If I drop the balls in here, it could hit my sensor and break it. So now we have our reagent, we have our steel balls in here, and we're going to measure out 20 grams of material in here. And we're going to put this 20 grams of material into my cap, which is on upside down, right? And I'm going to brush it in carefully so I don't lose any of that 20 grams. Remember, 20 grams is not that much. So we have to be careful. Once that's in there, right, I'm gonna take my cap, which has my soil sample in here, my balls and my reagent are down at the bottom, and I'm gonna turn it sideways and put it in. Why sideways? I don't want my soil to start mixing with the reagent until I have my gauge sealed off. Because if I let them mix before it's sealed up, gas will escape and it'll affect my results. So I got it sealed. I'm going to stand it up just like that, and I'm going to tap it, because now I want my soil to go down because it's sealed up and it's starting to react immediately. It's creating acetylene gas and lime in there, and the air pressure, the gas pressure from the acetylene gas is what's going to move my gauge. So now that I have everything in here, I'm going to turn my gauge sideways and I'm going to agitate it horizontally. Why horizontally? Because I don't want my balls to crash into my sensor at the bottom and damage it. So we'll do it for a minute for sand, like 3 minutes for a lumpy clay, and we'll do it. Once we finish, we'll look at our dial on our gauge. And if the dial has stopped moving, then we can record that information. If my dial has not stopped moving, that means we're still reacting. I'm going to agitate it for longer until it stops. Once it stops, I'm going to record that immediately. I'll record it immediately. I'm not going to do anything with it yet, because after I record it, what I'm going to do is turn it away from my face, because when I open this up, acetylene gas is going to come up. I don't want to get it in my eyes. I don't want to get it in my lungs. So I'm going to turn it away from me, open this up, remove the cap, and I'm going to dump it on the ground. Okay, so what am I looking for? Well, I'm looking for lumps. If there are still lumps in my soil, I'm going to have to rerun it. Okay, I'll rerun it one more time, run it for longer, agitate it for longer until I have no lumps. Once I have no lumps, I'm going to use that dial reading, and that's going to be my moisture content, except in the appendix of this book, there's correction factors for the type of soil that we're using. Now, if my soil is lime rock, I don't need to have any correction. If my soil is sand or clay or something similar, there's a correction factor that I'm going to record. There's a correction factor. I'm going to use that correction density in order to calculate my dry density. Now, dry density is equal to the wet density from my gauge divided by my corrected moisture content times 100%, and that's going to give me my dry density. I have my dry density, and then I'm going to take my dry density from that sample and I'm going to compare it to the proctor, or the maximum density that was obtained in the laboratory prior to the start of this part of the project. Then we're going to compare it. If they compare, fine, contractor's going to get paid. If they don't compare, there's a problem. The contractor may have to check his gauge again, or may have to rework the soil to achieve the proper density. Once that's done, then the contractor has met the requirements and the contractor can get paid accordingly. Now, there's two types of proctor. One is a proctor for base and subgrade, which is we call 90% of the modified proctor, and then, or 98% of the modified proctor. And then the other one for embankment and so forth is 100% of the standard proctor. Two different tests, okay? But you will learn more about that when you get to level 2, earthwork level 2, because we don't really study specifications in here. We're only learning how to use this equipment to get the results that we want in order to see if the contractor is meeting all of our contract requirements. And that's it.